So hi all, first of all let me welcome you guys to the Unacademy JEE English. This, as you know, is a brand new channel by Unacademy, which is India's largest online learning platform for iit-jee. Now this is a special series that I host for on every Saturday at 8:30, and this series involves some solving and problem discussion of Olympiad level problems, mostly from Pathfinder, as had been requested by a lot of you guys. So hello Arnav, Vansa, Banwal, how are you? And hello, Gopal Krishna. How are you guys doing? So, in the past three sessions, what we have done is we discussed problems of Newton's laws of motion. And today we will discuss problems from work, energy, and power. Okay, so before we get started with today's lecture, let me introduce myself one time for those of you who might not know who I am. So my name is Rohit Dixit. I studied mechanical engineering from IIT Delhi, and for almost past 8 years, I've been teaching physics for the JEE exam. And all this teaching had been offline, and offline I had been associated with some of the topmost institutes in the JEE field, IIT JEE preparation industry. Okay, so I myself as a student was All India rank 447 and All India rank 192 in the two stages of the IIT JEE exam that I took. So as I said, so right now you have two stages which you call mains and advanced. Back when I took the JEE, there were two different stages. So very similar to this. However, the first stage was called screening, and that was supposed to be an objective paper, and the second stage was called mains, and that was a subjective paper back then. So in the first stage, or the objective exam that I took, which was the screening, I was All India rank 192, and in the subjective mains paper, I was All India rank 447. I also had qualified NTSC stage 2, and I was also in top 1% in the NSEP as a student. Now I've already coached many students to top ranks in the JEE examination, both mains and advanced. Also guided a lot of students to great marks in Olympiads. So let's hope I can help you guys here now. So as I said before, this year all my teaching had been offline, and this year lockdown it forced all of us to adapt, all of us to change our habits. So I had to move online. So has been the case with a lot of you students. So how can you make sure that your studies are not getting disturbed because of this lockdown? Which chapter? So Gopal Krishna, today we will be talking about work, power, and energy. Okay. So have you tried solving problems from Olympiad, Pathfinder? Okay. So we will be taking up Pathfinder problems from work, power, and energy chapter. Okay. So as I was saying, so you students can also make sure that you are not missing out on your studies because of this lockdown, and the best way to ensure that is if you get yourselves the Unacademy subscription. This subscription will give you benefits like live classes, where you will get to interact with your educators on a regular basis. These classrooms will also have live polls and leaderboards, which keep them highly interactive. And you are also a part of a test series which is taken by a lot of students. Then you have analysis sessions so that you know where exactly you stand in the competition. And when NLM, so NLM I have already had three sessions. I have already had three sessions on NLM. Gopal Krishna. So I don't know if you haven't seen this, you can go in the video section of this channel. Okay, so every Saturday I've been taking series. So this is the fourth Saturday that I'm taking this now. First 3 Saturdays I took for NLM only. Okay, so if you want problems from NLM to be discussed, then you can watch those videos. Okay, and if there is any other problem that you want to be discussed, then you can write the problem number in the comment section, and I will take that up as well. Okay, so as I was saying, and all plus courses on Unacademy have this live doubt clearing sessions, which is a great feature. So every fourth session in Unacademy Plus courses is a live doubt clearing session. So that means your doubts never get piled up. Okay, so that is a great feature. And then of course you get the opportunity to study from the best teachers all across the country from the comfort and safety of your home. So I don't think you could have got something better out of this lockdown situation. So make sure you are getting yourselves this subscription and making the most of your studies. These are the online ongoing courses on Plus taken by the JEE English team. So there are 3 courses for class 11 students. So I myself am taking an advanced course on mechanics, and there are 2 other courses which Abhinav sir and Rahul sir are taking. Similarly for class 12 students, we have four courses going on the plus. Okay, so one, I'm taking an advanced course on electromagnetism. Then there are three other courses which are taken by Abhinav sir, Rahul sir, and Murli sir. Okay, so you can get yourself these subscriptions and join these, enroll in these courses if you want. So this is where you can find, and those who didn't know about this can also join these courses if you're looking to study in English especially. All right, so how do you get the subscription first of all? So very easy. First, you need to install the app. Once you have done that, then you need to go to the plus section of the app, select your goal as iit-jee and click on that get subscription button. Now, there is also the Unacademy Combat which is going on these days, right? You can be a part of that. It will be live tomorrow, and you can win big prizes. So if you want to enroll, you will be asked for a code also. So this is the code that you can use, RD Live. This is my code. You can use this code and enroll in the Unacademy Combat. Okay, do well there, and you can win a lot of cash prizes also. Okay, those of you who are following us on the JEE English channel of YouTube can connect with us on the Telegram app using this link. Okay, now, so are you guys ready for this session then? Okay, Gopal Krishna, are you still here? Or did you go to the NLM videos straight away? Oh, I think he has gone to the NLM videos. Wow. All right, how about others? Okay, so the only I keep repeating this. The only way that you can really benefit from these sessions is if you attend them live. So make sure that you're attending these sessions live, because without interaction you won't learn much. Okay, so I don't know what you guys, why are you guys not here? I would have expected more people online and live and interacting. Anyhow, let's wait for people, and why don't we get started with the first problem? So this is the first problem that I've taken up from the Pathfinder book. Okay, so I hope for those of you who don't know, this is the name of the book from which we are discussing the questions. The book is called Pathfinder Physics, Pathfinder, Pathfinder for Olympiads. So there is the book, Pathfinder Olympiad and JEE Advanced Physics. Okay, in case you don't know about this, you can look this book up. This is a book that has a lot of original problems and very tough problems in the collection. Okay, so a lot of students were finding a lot of difficulties in solving these questions, and that is where people had requested me to take some sessions where I will discuss and solve these problems. So, but I don't know. People who requested also, I don't think are coming online. They want to watch it in a recorded fashion. But trust me, when you watch the recorded session, then it might not help you much. It's always better if you attend these sessions live. So this is the first question that I have got for you from the topic work power energy of this book. So this question tells you that a solid right cylinder of length L stands upright at rest on the bottom of a very large reservoir. Okay, and you've been told where the depth is D. Okay, as shown in the figure. Okay. Now, you've been told that the density of the material of the cylinder is equal to that of water. Okay. So now the cylinder is slowly pulled out of water with the help of a thin, light, inextensible cord. Okay. As shown in figure 2. You have to find the work done by the pulling agent. Okay. So try this. Let's see if you can answer. No, I've taken three. I've taken 3 lectures on NLM. Look for it, Gopi Krishna. 3 lectures. I can also tell you the dates if you're not able to find out. Just keep looking in the videos, you will find them. There are 3 sessions on NLM, okay? So you can look for every Saturday, no? So what? Today is the 7th. So the last was on 31st. Before that would be on 24th October, and before that would be on the 17th. Okay, so you can see in the video section you will find 3 lectures. Okay, so in 3 lectures I think I was able to discuss around 20 problems, and I thought 20 problems discussion is more than enough. I should leave you some problems to solve on your own also. Okay, so I tried to discuss the tricky ones. Okay, how about this? Would you like to try this one out? Let me know. So anybody trying this? Hello Suraj. When density is equal to that of water, then shouldn't the body float? No. No, why would it float? It will remain at rest wherever you leave it, no? Wouldn't it remain at rest, Suraj, wherever you leave it? Why would it float? If I left it somewhere in the middle also. So imagine what will happen if there is water. Okay, this is our reservoir, consider filled with water, and I have this body which I'm leaving anywhere. So let's say I have this cylinder which I left here. Then here also, what is the net force on it? The net force would be zero, right? Because the buoyant force and mg would be equal, right? So here also it would not feel any net force. So if I left it here also, it would stay here. Okay, it will, as long as it is fully submerged, it will not feel any net force. Okay, the only time it will feel a net force would be when it is half submerged. Okay, so remember this. I hope you got what I'm saying. Okay, so think about this. Think how you will solve this. Think how you will solve this. So these are your options A, B, C, and D. Which one do you think is correct? I hope Suraj you're trying. So it would float. When will things float? Things will float if the buoyant force is more than the weight. No, then they will come up to the surface and they will come out, in fact, and then float. In case of equal density, I mean, think about this. Think about the water section only. Think about this water section. Isn't it in its place? So think about this water section. Can you say this is water? This is something that I put there. It has the same density as water. It will just remain in its own position, right? Won't it? If I put some water in a polythene, if I just drew boundaries around it, negligible mass boundaries. So this is the case, no? And how what? So can you be a little more specific about your question, Suraj? If you could be more specific about your question, maybe I can answer it better. I'm not sure I fully follow what you're trying to say. Okay. Let's see. I'm saying it wouldn't have felt a net force, right? If it was partially submerged, how would it feel a net force? Oh, because the buoyant force would have reduced, no? If this comes up, if this comes up, the buoyant force would be weight of this section, and the mg would be the weight of the total thing. So then of course it will feel a net force downward, because the buoyant force now would be less than mg. What is buoyant force? Buoyant force is the weight of the liquid displaced. Okay, okay. Alright, so why don't you try this? Try this and let me know. Okay, guys. Come on, I hope everyone's trying this problem. Hello Rajesh, how are you? So try this problem and try and give me an answer. What do you think the answer will be? What do you think will be the answer? Okay, tell me. Okay, Suraj, are you trying? Is there anyone else who's trying? Gopi Krishna, I think, immediately went to the NLM section. I think he was worried about NLM. He probably didn't want to pay much attention to this. Let me know who all are trying, so that I know who all to wait for. ट्राई कौन कौन कर रहे हैं बता दो, ताकि पता रहे भाई किसके लिए वेट करना है, किसके लिए नहीं करना. See, ideally, I would want everyone who wants to discuss the solutions of these to be live during the lecture, and everybody should be trying these questions first, thinking about these situations first, and then we can have a discussion. Okay, that would be the ideal scenario. Hello Shanta ji, how are you? Okay, please write trying in the chat if you're trying, by the way, so that I know I have to wait for you. So let me know if you're trying or you want me to solve this. I don't know. Okay, thinking. That's fine, that's fine. So at least I know one guy is thinking. So I'll wait for you, Suraj. You think about this. I want you to think about this. I want you to take your time with this problem. And then we will have a discussion about it, okay? Don't worry, there is no hurry. Okay, these are very, very good problems, okay? These are problems that you usually don't see. So I don't want to rush these. I want to just let you think about them. Oh, one more thing I realized in the last class. I made a small error. I don't know if I have this here. Yes. So when I was solving, yeah, here I had made an error. So let's just correct that. Where was the error? Yeah, here I took the mu out. When I took the mu out, I left this mu in here, which I shouldn't have done. Right, so this should not have been here, because mu I had already taken out. This here I put an extra mu, which I completely forgot. Then you would have realized, yes, then this is the situation that you would have had. Yes, AP, this is a tough one. This is the situation that you would have had. And this is nothing but M1. Okay, this would have been mu g cos theta times mu M1 M2 minus M double dash times M1 over M. Okay, this is what the expression would have been. And M double dash maximum can be M2. So you realize when M double dash is M2 in that expression, then your tension would reduce to 0. Similarly, M double dash minimum can be 0. If you put M double dash also 0, then also your tension would be 0. Okay. Oh, then the tension won't be 0. It would be something. Oh, I again am writing mu here. So this mu would also go. Okay. So the tension would have been maximum at the boundary only. And at the other end also it would have been 0, which is what I told you in the last class. That the tension would be 0 here. Would have been 0 here and 0 here. So you realize in here, if you put M double dash as M2, you will get 0, which will be the case here. Okay, so moving to today's lecture. MGL or 0.5 MGL. So which one? Which one? You have to pick one. No, it cannot be both, and you have to mark one. Of course, C does not even make sense. So I can simply eliminate C. Right? I can immediately eliminate C. Right? Then that leaves me with 3 choices. Now out of those 3 choices, you've already said 2. So pick one. How about others? Is anybody else thinking about this? So is there anybody else for who I should wait, or should I just go ahead and solve? Let me know. Hurry up, guys. Give me quicker responses, please. All right, Suraj, still waiting. So pick one, and then let's move forward. Okay. Can we get an answer or not? Alright, so should I just go ahead and solve this? Okay, so I don't know. So the correct answer actually is A. It's 0.5 mgl. So you have to think about this. So once what you will realize is that in getting this from here to here, the work done would be 0. There is absolutely no work required till this situation. Agreed? Yes, that is the correct answer. But how do you do that? So in bringing this from here to here, so initially it was here. Imagine initially it was here. In getting it from here to here, work done is 0. Right? Why? Because there is no net force which is pulling the cylinder down. Right? Yes, I saw that. So how are you getting that answer? That's my next question, of course. You can't simply just write an answer without thinking about it or without explaining it. So from here to here, the work is definitely zero. Why? Because there was no force. Because the force of buoyant force and the force of gravity would be balancing each other out. Okay. So the only work that the external agent would have to do is from getting it from here to here. This is where all the work would be done. Right. Work done on center of mass is 0.5 mg. Why? Why is so? Why is so? Well, Suraj is actually correct. So there are two ways of solving this. There are two ways of solving this. So you know that we can consider the center of gravity, and we consider that all the mg acts on center of gravity. Okay. So, but Suraj, don't you realize that center of gravity would have started feeling a force the moment this would have come up. The moment this would have come up. So imagine. Let's consider a situation. Let's just study this in detail. Just think about it in detail. So consider a situation where you have water up to here, and you have this cylinder which is partially submerged right now. Okay, let's assume that this is the case. Okay, so in this case, what is the net downward force that it is feeling? So imagine if x part has come out, or you can also imagine. So if x part has come out, so you realize what will be the force that is required to just hold it. What is the F that is required to hold it in equilibrium? Now, pay attention to the language. The language says that it is pulled out slowly. Pulled slowly. So if it is pulled slowly, then it has to be in equilibrium at all times. Right. So what I will do is I will try to find the F which is required if it is being pulled slowly. So I hope you understand that. So since the cylinder is pulled up slowly, so what I can say from here is, therefore it must remain in equilibrium at all times. Correct. You follow this? So let's say if x length is out, then what is the force that is required? Therefore, F required for equilibrium when x length is out, x length is out of water. What will that be? That will simply be the weight of this part. Do you agree? It will only be the weight of this part. I hope you realize this. It will only be the weight of this part. Okay, so let's try and draw that again. Do you agree? Because for the portion below, the weight of the portion below will be balanced by the buoyant force. Agreed? Do you guys agree? Tell me. F would be the weight of the x length of the cylinder. Can I say F would be equal to would be equal to xm by L, which will be the weight of mass of the x length of the cylinder into g. Do you agree? How is equilibrium happening? What do you mean? Draw all the forces, no? Draw the forces for this part, See, what are the forces? Okay, let's draw all the forces. For this part, you will have the mass of this, or let's say total mg. Okay, total mg F, and then you have a buoyant force. These are the three forces. Agreed? These are the three forces which will act. The force by the external agent. External agent is pulling it, no? Maintaining it in equilibrium. Okay. See, till the time it was completely submerged, there was no net force. So the external agent would apply negligible amount of force and be able to pull it up. But the moment some part gets out, now the buoyant force can only balance the weight of this part. Okay, buoyant force equals weight of this part, because buoyant force is the weight of the liquid displaced and this is the volume of the liquid displaced, and since the density of water and the cylinder are same, so you realize that weight of this part would be equal to the buoyant force. So these two are balancing each other out. So F has to just balance the weight of this part. F has to be equal to weight of this part. Weight of this will get balanced by F. Got it? Now is it clear? So weight of this part would be x mg by L. I'm assuming the cylinder is uniform, which must be given. Okay, solid right cylinder, let's assume it's uniform. Okay. Okay, so now the moment you displace it by further dx, okay, the moment it is displaced by a small amount dx, then you know the weight, the work done. The moment I displace it by a small dx upwards, what is the work? Therefore, dw, work done by external agent, this will be the force by external agent. Work done by external agent would be x mg over L, okay, into dx. All you need to do is integrate this, and when you integrate this, x will vary from 0 to L. Correct? So that will give you that work done by external agent would be equal to mg over L into L square over 2, which is 0.5 mgl. Got it? So work done on the center of mass would be actually slightly difficult to see, no? Wouldn't it be? What you could have said was maybe from the potential energy, because initially the potential energy is not changing if you apply the net force thing. So it does not have any potential energy. It does not have any potential energy till it's submerged. So other way of seeing this is that it does not have any potential energy till the time it is submerged. Why? Because the net force is zero. If the net force is zero, then potential energy is always associated with the conservative force. Okay, so that you I think just made it 7. Congratulations, Om. Okay. So this is one way of. I'm not quite good at hydrostatics. Okay, all right. Maybe you should. Forget about this. Another way of looking could have been that every potential energy is associated with a conservative force. Okay. So while it is inside, the conservative force of gravity is being cancelled by the buoyant force. Agreed. So till here, I can assume that there is absolutely no potential energy. Okay. So up till here, there is absolutely no potential energy. If the potential energy is zero here, then it will be zero everywhere. because beyond this point, the force of gravity is getting nullified all the time by the buoyant force, right? So beyond this point, the potential energy will be zero at all points, So from here to here, the potential energy does not change. From here to here, there is no change in potential energy. When this completely comes out, then the potential energy of the system becomes zero point 0.5 mgl, and that is the work that would have been done by the external agent. Okay, so there are two ways of solving this. In fact, I did not want to go into the potential energy because I don't know if you will really realize that the potential energy, if the force of gravity disappears, then the potential energy cannot change. Right? Change in potential energy is work done by all the conservative forces minus times work done by all conservative forces. So here the buoyant force effectively cancels the G. So G effective is zero. So G effective is zero. So I can say in this entire region there is no change in potential energy. This entire region or depth would have been equipotential. Okay. Alright, so this is the solution in any case. This solution does not require any other concept or any understanding of that. This is a very simple calculation of work. So find the force, integrate f dx, that's it. Okay. Alright, let's move on to the next question then. So you can choose the approach that you like. If you understand this one, if you understand that the potential energy below the liquid will be zero, then you can use this, which is what I think which is what Suraj did intuitively, right? And this is the work, this is the approach of calculating work from f dot dx integral. You can apply any approach, both of them are correct. Okay, not a problem. Now let's solve the next problem. The next problem says that the potential energy function is shown in the graph. Okay, now a particle moving in this potential field in the positive x direction possesses 1 joule of kinetic energy when the particle is at x equals 1. So this would be x equals 1, this would be 2, 3, 4, 5, 6, 7, right? And these are the potential energies 1, 2, 3, 4, 5. Okay, when it is at x equals 1, it contains 1 joule of kinetic energy. Where will it reverse its direction of motion? Where will it reverse its direction of motion? Okay, that is what you have to find. Yes, I figured through it. That is why I told you immediately you are correct. I understood what you are trying to say. Okay. But you have to do that with the right reason, okay? So the change in potential energy. I mean, somebody could have also said this, no? Somebody could have also said this. So the idea is you have to add the potential energy due to the buoyant force also. Buoyant force also acts like G, right? That's why we call G effective. No, buoyant force is upward G. So you have to take the potential energy due to the buoyant force also into account. Okay. All right. Here. So where will it reverse its direction? Tell me. Where will the particle reverse its direction? So try this one. Okay. So who all are trying this? Please write trying in the chat. Write trying in the chat if you're trying this. Okay. So guys, don't be so lazy, just try trying in the chat. That helps me decide who all to wait for and how long to wait for. Okay, so Tanya is trying. Great. Thanks for letting me know. Suraj is also trying. Great. So at least two people are trying now. So I know it. I know at least I have to wait for these two before I solve this or before I share the solution. I have to give these guys a chance to solve this and think about this. Okay, how about others? Okay. Think about this. I hope you understand how UX graphs work. Right? D. Okay, so Tanya says it's D. Let's see if she is correct. How about Suraj? I hope you know the relation between force and its potential energy function and its graph. So potential energy function has been shown. Okay, I hope you guys know the relation between the force and the graph. How can we determine the nature of the force with the help of the graph? So tell me, Suraj, how about you? Do you have an answer or should I go ahead and solve? Let me know. So Suraj says C. Alright, so no, the correct answer is in fact D. So well done, Tanya. Alright. See, the logic is first of all you should know that conservative force is minus du over dx. This is the relation between a force and its potential energy function. Okay. So see, the potential energy function has been shown. So this function represents the potential energy at any x. At any x, what would be the potential energy of a particle? If the particle was at x equals 0, then it would have had a potential energy of 1. If it was at x equals 1, it has a potential energy of 3 and so on. Okay. Now you have been told a particle moving in this potential field in the position of in positive x direction. So particle is already moving in positive x direction. This you have been told. Okay, because of which it has some kinetic energy also. So it has some V and it has some kinetic energy because of that. Now it possesses 1 joule of kinetic energy. So K you've been told is 1 joule. So it was moving in the positive x direction and at x equals 1 it has this energy. Now when will it reverse the direction of motion? Why would it reverse? First of all, let's think about this. So if you know this, then what does that mean? That means that whatever conservative force, as I don't know if you've watched my lectures, I don't know if you know this, that every potential energy is associated with some conservative force, and the conservative force and its potential energy function are related like this. So whatever conservative force is causing this kind of potential energy. See, in this region, from here to here, let's take it region by region. So from here to here, you realize the slope is positive. Du by dx is positive. So if that is positive, I will realize that Fc, the force, conservative force, would be negative. So in this entire region, the force would be acting in this direction. Okay, it would have a negative direction. Similarly, in this region, you realize du by dx is negative. The slope is negative. So in this region, the force would be positive, which means the conservative force would act in this direction. Okay, somehow it must be happening. I don't know how, what is causing the force to immediately reverse its direction, but this is what we can infer from the graph. Similarly, in this entire region, du by dx is again positive. Slope is positive. So in this entire region, the force would act in this direction. Okay, so first of all, you need to understand the directions in the entire region. So when you are moving from here along the x-axis, so from 0 to x equals 1, there would have been a force in this direction wherever you were. If you were here, you would have felt a force in this direction, in this entire region. In this entire region, from x equals 1 to x equals 2, if you were anywhere here, then you would have felt a force which was in the opposite direction. Okay, from here to here, you would have, if you were here, suppose, you would have felt a force in this direction. So anywhere between x1 and x1 and 2, you would have felt a force towards the right or the positive direction, positive x. Okay, that is what I'm trying to say. This is the negative x direction, minus x direction. This is the plus x direction. And similarly, beyond x equals 2, the force would have, at all points, would have acted in minus x direction. Okay, did you follow this, Suraj? Let me know if you followed this. Did you know this relation? If you knew this, then you would be able to follow that. Maybe you did not know this. So whatever force is causing this potential energy, that force behaves like this. That force acts in the negative x direction from x equals 0 to x equals 1, acts in positive x direction from x equals 1 to x equals 2, and beyond x equals 2, it acts in the negative x direction. Okay, got it? Great. So you have been told that at x equals 1, it had a velocity in the positive x direction, right? It was moving in the positive x direction here. So here it was moving in the positive x direction with some v, right? So in this region, from x equals 1 to x equals 2, it would have accelerated because the force would have acted in this direction. So when it reached here, it would have gained some kinetic energy, v dash, the speed would have been. Now, as it moves forward, its speed would have reduced continuously because the force is in the opposite direction. At some point, it would have come to stop. Okay, and then because of this force, it was a reversed its direction. Okay, did you get it? Because of this direction of the force, it would have gotten retarded. At some point, the velocity would have become 0, and from then on, because the force in entire region is in minus x only, so when it stops, it's still feeling a force in minus x, so it would have started going back. Okay, so where will it reverse the direction? Wherever v becomes 0. Okay, so we know particle will reverse its direction, from the point where its v becomes 0. Oh, you didn't know the relation. Okay, but now you know. So you can again watch my series on work power energy. There I have discussed this. This is a very important relationship. A lot of questions have been asked in the JEE exam. I don't know how you don't know this. Okay. Now, all you know is that since the only force acting is conservative, so the total mechanical energy should be conserved. Okay, so I can also write also since no non-conservative forces are present. So since no non-conservative forces are present, so can I say total mechanical energy will remain conserved? Okay. The total mechanical energy remains conserved. Correct. Now it is very simple to see. Now it is very simple to see. So what was its total mechanical energy at x equals 1? So let's try and find the total mechanical energy. EME, what is the total mechanical energy at x equals 1? So x equals 1, I can see from here, it has a potential energy which is 1, 2, 3. So plus 3 potential energy. Okay. So plus 3 plus 1, that is plus 4 joules. Plus 4 joules is the total mechanical energy at x equals 1. Now, when it has to reverse, I have told you that its V becomes 0. So at the point where it gets reversed, all the energy would have gone into the potential energy. Okay, therefore, can I say that at the point of reversal, U should be equal to plus 4 joule. Right. Now look at the graph. Now look at the graph. So U should be 0.4 and 4 it becomes here. So the corresponding value of X is 6. Okay, so here the entire kinetic would have converted into potential and it would have come to rest, and from here it would have come back. So the answer was X equals 6. Got it? Take a look at the solution. This is a very simple solution. I didn't realize that you guys will not solve this. I thought everybody will solve this. This is a very simple problem, and this is a good problem for advanced. I think this is one problem which is very much at the advanced level. Okay, so did you follow this, Suraj? Tanya already got this right. How about AP? AP and Suraj, you guys followed this? Let me know. And next time you remember this. Next time remember this, that a conservative force is related to its potential energy function with the help of that relation. F conservative is equal to minus du over dx. This is for 1D, by the way. For 1D. For 2D, 3D, it takes a different form. Okay, that also I have discussed in my lectures. So in case you need more details on this, you can watch my lecture on work, power, and energy. Okay. So I hope everybody followed this. If you have any issue, then let me know. Otherwise, I'll move ahead and we will move to the next problem. Everybody followed this? Okay, I hope so. Alright, so here is another problem. So you've been told a ball of mass m is suspended from the ceiling with the help of an elastic cord. Okay, an additional downward force applied on the ball, if increased gradually to a value of F naught, the cord would break. Okay. Now, what should be the additional minimum constant force F that will break the cord? So if body reversed at x equals 6, why is the graph showing at x equals 7, 8 and so see, the graph is showing wherever the body could have been. If had the body been at 7 or 8, it would have had that potential energy. But the body has a total mechanical energy of 4 only, right? So it can never go beyond that. It will never be able to go beyond that. That is the potential energy that a body can have when it is kept there. Does not mean that the ball can go there. If some other body is kept there, if the ball is kept there, then it is going to have that much potential energy. That is what this is. It is showing you the variation of potential energy with position. I'll tell you. I'll explain that to you with an example. Okay, so let's consider an example. I am projecting something from ground. Okay, I'm projecting something up from ground, and can I say if for a mass of let's say 1 kg. So if Mass of the body projected up is 1 kg. Then at a height of 10 meter, what will be the potential energy? The potential energy would be mgh, so it will be 100 joule at h equals 10. So here you have height, here you have u, and I can say that at 20 it would be 200, and I can say at 30 it would be 300, and so on. Okay, so can't I say that? Now if you project something, with a speed of, let's say, 10 meter per second. Okay, so, or less than that, let's have it less than that. So imagine you projected something with, let's say, something with 5 meter per second. Okay, something with 5 meter per second. So what is the maximum height that this can go to? I hope you remember h is equal to u square over 2g. So that will be 25 over 20, which is 5 by 4. Or this can only go up to 1.25 height, right? But I can still show you that at height 30 the energy would have been 300 joules. Did you get that? The graph is showing something else. This is saying had something been here, then its energy would have been this. Does not mean whether this can reach that height or not. That is dependent on this. Okay. Does that make sense? Now is it clear? Me marking these values does not mean whether this guy can reach there or not. These values are true whether this guy reaches there or not. Agreed? Okay. That is what is happening in the graph. Okay, that has got nothing to do whether the body can reach there or not. If somebody reaches there, if this body reaches there, then it can have that much energy. Alright, so how about this one? Let's try this one. A ball of mass m is suspended from the ceiling with the help of an elastic cord. An additional downward force applied on the ball, if increased gradually to a value of f, if not, can break the cord. Okay. So what would be the additional minimum constant force which would have broken the cord? Okay, let's try this one. Well, I have a couple more very interesting problems. So this is a very interesting problem. Okay, and this is a very interesting problem. Yeah, this too. A lot more interesting problems coming up. So hurry up with this. This is a simpler one. Okay, I personally find this. I thought, in fact, all the problems till now were simpler. Anyhow. How about this? Try this. Because I am more excited about the problems that are coming up next. So I want to move ahead from here very quickly. Next few problems are very interesting. Very nice situations. Okay. So try this. And those of you who are trying this problem, just don't be so lazy and just write a small trying in the chat so that I know that I have to wait for you. Okay. Hurry up, guys. Come on. Alright, so Tanya and Suraj are trying again. Good to see two hardworking students. So trust me, I'm as a teacher always going to be proud of any of my student who always tries hard, irrespective of the result. It is your effort that really counts. That really tells that you did something. A lot of other factors will determine whether you were successful or not, which does not really matter. What matters more is that you tried. So trust me, I'm always happy and proud of students who try things. For me, the result honestly doesn't really matter much. I mean, yeah, of course, it would matter, but I think effort. If you're putting in effort, then that says a lot about you. And if you keep putting in effort, so you may not be successful in one thing, maybe in the second thing, but you will eventually be successful. Okay, so that is what I believe, and that is why I would encourage all you guys to put in some effort. Okay, so what do you think? What do you think is happening here? So I don't know. Have you ever tried this? Have you ever stretched a rubber band? If you keep stretching it, at some stretch it breaks. Right? At some point of stretching, it breaks. So it's a similar thing that is happening. If you stretch something beyond a point, then it will break. So that is what you need to know, by the way. In case you don't know, let me give you a hint that you need to stretch that by a certain amount in order to break it. This is your hint. If you can stretch it by some amount, let's say x1, it will break. So to break an elastic, you have to stretch it by some minimum amount. Okay, so what constant F would make sure that it produces the same extension as a gradually increasing F naught would have produced. That is what you have to find, which should be easy now. Okay, so again, you have to imagine, you have to assume, though it has not been written, but you have to assume that the elastic properties keep holding. Okay, C, no, C is, let's see. Let's wait for others also. So Tanya says it's C. She thinks it's C. How about Suraj? Okay, anyone else who's trying and who wants to take a shot at this? If you are trying and if you got an answer, you can write your answer in the chat. And don't worry if you'll be writing the wrong answer. That's perfectly all right. This is a discussion session. This is not your test. Okay. So it's okay if you get it wrong. That is why we are having this discussion. We will try to analyze where you went wrong and we will try to correct it. Okay. So Suraj, do you have an answer? Or should I go ahead and solve this? Let me know. Okay, S Pandey says D. Okay, so I'm getting two different answers. Wow. Interesting. So A and B are the only options left, right? So, know what? You're not getting the answer. Or should I not solve? Please be a little more clear in what you're trying to say. Let's see. Okay, I think no, I don't have an answer. Okay, okay. So the correct answer, by the way, no, C is wrong, D is wrong. The correct answer was A. Okay. Sorry, Tanya. Sorry, S. Pandey. But that's all right. That's perfectly all right. So these are supposed to be tough questions. So even if you got them wrong, that is absolutely fine. So first, let's imagine that this had some extension. It had some extension of x naught already when this ball was hanging. And once you start applying a force which is increasing gradually, if it is increasing gradually, it will slowly stretch. It will slowly stretch up to a point where it will be in equilibrium again, where the force becomes F naught. Sorry, it will remain in equilibrium at all times, by the way, because it is being moved slowly. At when the extension becomes, let's say, some x1, I am assuming it got stretched by x1 again, then the force has become F naught. Okay, so I can say since for the entire journey it was being moved slowly, so the equilibrium should always be maintained. And if this had a spring constant or elastic constant of k, then I can say so since the force was increased gradually, therefore equilibrium at all times was maintained. All right, I can conclude that. Therefore, at the final position also, I can say that F naught plus mg should be equal to k times x naught plus x1. Okay, I hope everybody gets that. Also, kx naught would be equal to mg. So these two equations I can say because equilibrium was there at all times. So when the elongation was some x naught, then it would happen kx naught would happen equal to mg, and when the force was applied, then also at equilibrium when the string broke and the elongation was x1, then also this would have been the case. Okay, so let's call this equation 1 and let's call this equation 2. Now if a constant force is applied, then what happens? Let's see the alternate scenario when the force applied is constant. Okay, so it already has elongation x naught and it has mg, and let's say some constant force F is applied. Some constant F is applied. Now it would have accelerated first. Okay, then at some point the net force would have been zero, and then it would have retarded, and then at some maximum elongation it would have again come to rest. So I want it to go to the same value of x1 so that the string can break. However, at in this scenario, at maximum this at the maximum elongation, this velocity would have become zero. Consider this is something similar to when you leave a mass attached to a spring to free fall. So it accelerates, then it retards, reaches a maximum elongation, then comes back. Right. So that is what happens. So a similar thing would have happened here also. Okay. Now for what I can say from, so this is our initial position and let this be our final position. Now between initial and final I can apply the work energy theorem. Okay, let's applying the work energy theorem between the initial and the final position. Initial is when it was the elongation was x naught, and final is when it has elongated by x1. Between initial and the final, situations or instance. Let's write instance. So what all can I say? I can say that the work done by the force F, which would have been F times x1. Why? Because this is a constant force. I can say F times x1, F times x1 should have been equal to the change in potential energy plus change in kinetic energy plus change in, so there are two kinds of potential energies. So change in gravitational potential energy, which would have been minus mgx1, okay, plus the spring would have gained some potential energy, okay. Potential energy gain would have been half k times x naught plus x1 square. This would have been the final potential energy minus x naught square. Agreed. And the kinetic energy changes from 0 to 0. Do you realize that this is the equation for work energy theorem? If you have any objections, anyone has any objections about this equation, then let me know. Is everybody fine with this? Do you understand how I have written this? Work done by F would be equal to the total change in potential energy and the total change in kinetic energy of the system. Now the kinetic energy was initially 0, is finally 0. The potential energy has changed in two ways. The gravitational potential energy has become negative or has reduced, and the stored energy in the spring or the string has become higher. Okay, so let me know if you're following this. Some active response would be really nice, because otherwise I'm just going on explaining and I don't even know if you guys are following this. Okay. So I will continue to solve then. So from here what I will say is that fx1 would be equal to minus mgx1, and this I can write as half k times, this will be a square minus b square, so that is a into b, a plus b into a minus b. So a plus b, which is x naught plus 2x1 into a minus b, which is x naught. Right? Okay, great. All right. So I hope this also should be easy. So let's move on to the next page, and let me add a page here for the solution. So what were the equations? So let's rewrite all the equations so that we're not getting confused. So the equations that we had were, one, we had f naught is equal to k x naught plus x1 minus mg. Hello Srinjoy, you are late. So that was one. Okay, this one, I have written this one here. I've just taken the mg on the opposite side. Okay, nothing else. It's the same. Next, let's take this one and also write this. So next I know that kx naught would be equal to mg. This is the second equation. So the only reason why I'm highlighting is so that you guys can realize which equation is which, and I know that I'm not making a mistake. Yes, Rinjoy, I do remember you. You are late. I was expecting you to be here earlier. All right, and finally, let's talk about this. This let's call our third equation. So this is fx1. fx1 equals minus mgx1 plus 1 by 2 k times x naught plus 2x1 naught plus 2x1 times x naught. I think that was it. Yes. Oh, yes, sir. Sorry, I'm late because there was no current in my house. Oh, Okay. No problem, no problem. Good to see you here. Now also it's all right. All right. So this is the third equation. Okay. Now let's just solve these and find the value. Okay. From here I can write fx1 would be equal to, and here I can say, so let's open these brackets and I can say minus mgx1 plus I can write half kx naught square, right, and then I can write plus kx1 x naught. Okay, fine till here. Okay, keep letting me know. Next I can say that fx1 would be equal to, so half kx naught square plus I can take out x1 common, and if I take x1 common I'm getting kx naught minus mg. Correct. From this equation, from 2, what you will realize is that this is 0. Okay, great. So now what do I want to do? Now all I want to do is I want to replace the value of x naught somehow, because that is the only variable that I have, or the value of x1. So I can do anything. I can either replace x1 or I can try and replace. So again from here also, in here also, here what you will realize is that kx naught, from, if I use these, if I use this, can I say that f naught would be kx1? Agreed? I hope you realize this. Third equation is miswritten. Okay, fx1 minus mgx1 plus half k x naught plus 2x1 into x naught. No, I don't think so. Applying work energy theorem. So work done by the force F would have been F times x1, because the elongation was x1. Okay, and this should have been equal to the loss of potential energy, which would have been minus mgx1, which is also fine, and the change in potential energy of the spring. So initially the spring had a potential energy of this. Finally it has a potential energy of half k x naught plus x1 whole square. Initially it had a potential energy of half k x naught square. So no, it is not. It is not wrongly written. It is absolutely fine. Okay. No, nothing is wrong about this. Then this becomes a minus b into a plus b. Oh, here it should be x1. Is that? Instead of x naught. Oh, yes. Oh. So it should be 2x. Oh, yeah. Yes, I do these things. So a plus b into a minus b. Yes. I just noticed. Yeah. I keep doing that. X 1, 2. I will change the subscripts. Uh, let's just correct it. No problem. We will just correct it. Thank you for pointing that out. 2x1. Okay. And then what would have I had? Okay. So let's just rewrite this from here. No issues. Thank you for pointing that out. Yeah, I do make such mistakes. Last time also I took mu common and I left one mu inside the bracket also. So yes, thank you for noticing that, because I, as a teacher, have become a slightly careless about my problem solving. I usually don't like solving the entire equation. So whenever I do, I make such silly mistakes. Ha. Okay, so let's see, fx1 equals minus mgx1, and here I would have had plus k x naught x1 plus half k x1 square ठीक है, अब सही है. F x1 becomes equal to x1 taken common k x naught minus mg plus half k x1 square. Okay, is that fine now? Yes. No, especially as a teacher, I'm allowed to. As a student, I wouldn't. I wouldn't. But oh, no, even as a student, I did. Yes. All right. So we have this. Okay. Okay. So we have this. So what I'm getting is I can take out. Oh, I could have taken out this. Yeah. Yeah. I could have just taken out this. So I'm getting F equals 1 by 2 kx1. Okay. And I already knew this. Okay. From here you realize kx naught and mg will get cancelled. So can I write f naught will be equal to kx1? Yes, 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 I did. See, earlier it was not cancelling out. No, so that is why I hadn't. Now I just realized that it is cancelling out. So I did. Okay. So now all I need to do is replace kx1 by f naught. So if I replace that, this is f naught by 2. And that is my answer. Okay, got it? So the correct answer is option A, f equals f naught by 2. Right? Followed this? So should we move ahead to the next problem? Next problem is something that I'm very excited about. Okay, let me know if there was any part that you did not follow. Let me just show you the entire solution. Okay. And see, Suraj, there is nothing sneaky about any solution that I'm showing you. Because you had that complaint last time, I remember. Not related to my videos, but you were just mentioning that most of the solutions that you see are sneaky ones. Alright, Stranger says, let's try the next one. This is the one that I was excited about. So try this one. This is a very interesting situation. Okay, interesting situation. That is the only reason why I'm excited about it. Okay, so everybody followed it. Great. So now you've been told two identical ropes A and B of uniform mass per unit length are suspended from the ceiling and are made to pass through a metallic tubular structure C as shown in the figure. The structure is made by welding two identical bent tubes. Okay. There is no friction between the ropes and the tubes, and the structure is almost inertialess. Okay, so no, I won't give a timer. You can take your time. It's okay. It's okay. You can take your time. Or okay, so there is no friction between the ropes and the tubes, and the structure is almost inertialess. Inertialess means massless. Okay, so I hope everybody understands that inertialess essentially means massless, right? So initially the structure is held at rest and then released. What will happen? Option A says it will move. It will not move at all. The rod that you have connecting these will not move at all. Option B says it will move downwards with a speed decreasing at a rate of 0.5 g. Option C says it will move downwards with a speed increasing at a rate of 0.5 g. Option D says the rope will heat up. Okay. So which do you think is the correct? Okay, so AP has given an almost an instant answer. See, okay, let's wait to find out if you were correct is AP or not. Okay, how about others? So just write trying in the chat so that I know you guys are trying and I'll wait for you. Okay, so enjoy. So just write trying in the chat so that I know you guys are trying. The answer is A and D. Okay, so enjoy says A and D. So if it will not move at all, why will the rope heat up? Why will the rope heat up if it does not move at all? So enjoy. If something is at rest and remains at rest, then why would the rope suddenly start getting heated up? So A and D, does that even make sense? A and D being correct at the same time. Can A and D be corrected simultaneously? Think about it. Suraj is fine. So enjoy. Think about your answer logically. Can it happen that the rope nothing ever moved and the rope just started getting warm or started getting heated up? How is that possible? The reason for A is it is not to move since structure is symmetric and unbalanced. Unbalanced. Reason for D is it will heat up due to tension in the string. Okay, that is weird. So heat is a form of energy. First of all, heat is a form of energy. So if the rope is getting heated up, where is that energy coming from? Where is that energy coming from? Think about it. Just the tension cannot cause anything to heat up. Tension alone cannot cause anything to heat up. Let's think about this. Let me tell you. Imagine this is the phone. Okay, this is hanging like this. So there would be a tensile force in this entire thing, right? There would be a tension in the entire body of the phone. Do you think if I kept hanging this, it would start getting heated up? Assuming it was off and I'm not playing games to heat it up. From hanging the phone, can I heat it up? Just leave the phone hanging. You think it becomes hotter after a while? So tension is acting. Tension is acting in the entire thing, right? It is the tension, internal tension, that is keeping this, that is balancing the forces, right? So if I talk about this part, the weight of this is getting balanced by some kind of tensile force, internal tensile force, but this will not get heated up, right? So think about this. Also, heat is a form of energy. Where is that energy coming from? So whenever you give an answer, just take 2 minutes to think about it. Okay, but it's all right. It's all right. Since we are having a discussion, so I'm glad that you said that so that I can point out the errors. And I hope you realize now that what you were saying has some flaw and where that flaw is. Think about it. First, having tension does not generate heat. Let me clarify that thing first. Just having tension anywhere does not generate heat. Okay. Heat just does not get generated due to tension alone. There has to be something else to create heat. Some energy. Second, obviously, think about it in terms of energy. Heat is a form of energy for you, for the rope to get heated up. That energy has to come from somewhere. If nothing was moving, if everything was just stationary, so where is that energy coming from? Okay. All right. That I hope makes a few misconceptions if you had any clearer. And I want you to think about this. Okay. Just in case, stranger, it's been 5 minutes since I gave the problem. Since you had asked for a timer. So it's been 5 minutes since I have given this problem. Okay, so how many problems have we discussed? Very few, I think. Yeah, one, two, three. That's it. One, two, three, four. I had planned to discuss 7 problems, out of which we have already discussed 3 right now. Okay, so the answer is C. Srinjoy now says C. Okay. So which was said by AP also. We will see. Oh, by the way, the time is up for today. The session I had planned for from was supposed to be from 8:30 to 10. See the chat? I answered. Yes. I saw the chat. There is a small delay. Okay, in all live streams we keep a small delay so that the stream runs smooth. Okay. So if I do not answer you immediately, that is because I have seen it. I have responded to it. But you will see that stream of my response in a few seconds. So whenever you write something in the chat, just take like 5 to 10 seconds. Okay, and wait for 5 to 10 seconds for my responses. Okay, how about Suraj? Suraj, do you have any answers? So what I want to do is I want to tell you the answer right now, and I think we will plan it in the next session that we have. We will discuss this problem in the next session. Okay, because we have run out of time for today's session. Till then, I want you to keep thinking about this also. This is an interesting situation, and there are other 3 problems which I wanted to discuss today. So I want to give them to you as homework also, so you can try those also. And then in the next class, maybe we will discuss those as well. So the correct answer for this one is C and D both, by the way. Okay, that is the correct answer. The correct answers are C and D both. Okay, now you think about it. Okay, so this is another problem. This I think you can discuss in we can discuss in the next class only. And this also maybe we can just discuss in the next class only. This is another very interesting problem. The answer was C and D. C and D both are correct. C and D both are correct. Okay. Why? That I will discuss in the next session. Hint. Okay, hint of what? Think of the forces. Think of what forces are doing work. This is the chapter work energy, no? So think of work and energy. That is the hint. Okay, here is a question which is a very good question, which I found was a very interesting problem, and this is what I want you to try. Okay, so this you can take as your homework problem. I want you to try this, and we will discuss this. We will discuss the solution in the next session. Okay. So this is a very interesting problem. So was that, by the way. The rope one was also a very interesting problem. So some very interesting situations and very interesting problems in this book. That is why I did decide to take up the solution sessions of this book, because this has presented some very unique situations which you have never seen before. So the one I like 2 things about this book. One, it presents unique situations. So situations which you're not used to. So it requires you to challenge your brain. So that is a very good part. Second, I don't think I've found any error in this book. So that is one thing I really appreciate in a book of questions, that it should not have any errors, because errors would confuse students more. Yes. So take a screenshot of this, and that is where I would wrap up today's session. So okay, let me give you 10 seconds to take a screenshot of this. Okay, so you have 10 seconds to take a screenshot of this. I did this question before. Answer is B, C, D. Sure. Yes, that is correct. That is correct. So enjoy. So B, C, D are the correct answers. You are absolutely right. Okay. So well done. Alright, but we will still discuss the solution in the next class. Alright, that is where I would like to wrap up today's session. Again, before I leave you, let me remind you, if you haven't gotten your Unacademy subscriptions and you're planning to, this is how you do it. You install the app, then you go to the plus section of your app, then you select your goal as iit-jee and you click on that get subscription button. And when you do that, you will be redirected to the payment page. That is where you can use this code RDLife to get your subscriptions. Alright, this code will give you a 10% off. All right. So in case you're wondering why you should be taking these subscriptions, so this is one incentive for you. So the JEE English team is taking a lot of courses on online on the Plus app. So if you want to be a part of those regular courses, then you can get your subscriptions. The constraint motion and energy conservation concepts will be applied. Yes, of course, of course. All right, and these are the courses which are available for class 12 students. Okay, and if you like today's video, then press that like button, share it with all your friends, and make sure that from the next class you are discussing this live. Attend their session live. This is one session that you should always be attending live. I believe you should attend all the lectures live only. That is when you will benefit the most. If you don't attend sessions live, then trust me, you lose out on a lot of discussion or a lot of insight that you could have gained by having a discussion with the teacher. So I would advise you to attend all these sessions live only, at least this one. Sir, I'll be on 11th next year. I will join Plus. All right, great, great, great. And then I will see you there. So enjoy. Don't forget to use the code RD Live. Okay. And for those of you who are following us on the JEE English channel, can connect with us on the Telegram app using this link. All right. So as I was telling, so enjoy. If you're planning to get your Unacademy subscriptions, this is the code that you can use to get your Unacademy subscriptions. This will get you a 10% off on all the fees. Okay. So that is it from my side. I will continue meet you with this session. The next week, I think yes. Next week I am not taking this session. Next week I think would be very close to Diwali, or I think is it Diwali only? Yes, next week. Okay, yes, 14th of November is Diwali, so that day I'll be taking a break. So happy Diwali to all you guys first of all, and we will meet after 2 weeks now. Okay, no, not next Saturday. So enjoy. Not next Saturday. Next to next Saturday. I will see you guys on probably on 21st. Okay, so 21st of November is probably when we will meet again. Next Saturday, I think there is Diwali. Okay, so I will be spending time with my family, and you should do the same. All right. Besides that, keep studying hard and always keep practicing. All right. So happy Diwali once again, and I'll see you next on the 21st. Okay.